as you can see, I don't have any base here, so that means my base is 10. So this one is 36, and I know that 36, maybe I should write that. So 36 is 6 squared, is a perfect square, and is 6 squared. And by that property, by the third one, instead of log of 36, I can write log of 6 squared because they're equal. Then by that property, I can move this power to here as a coefficient, and then I can make it 2 times log of 6. So instead of log of 36, I can write 2 log of 6. So I can write that here. So I would have 2 log of x minus 3 equal 2 log of 6. And then I can divide both of them by 2, and then these 2's cancel. So these 2 cancel. So I have log of x minus 3 equal log of 6. So we don't have to change to exponential form. When I have log of something equal to log of something else and the bases are the same, I can set the arguments equal to each other. So what I just said was this, that when I have log of x base b equal to log of y base b, that means the arguments are the same. So maybe we can add that to our properties of log. So here I can set x minus 3 equal to 6, and then plus 3, I get that x is equal to 9. We can check that in our equation. So if I have x equal to 9 and plug it in here, so I would have x minus 3, which is 6, and I have log of 6, and 6 is a positive number, so that works. And x equal to 9 is our solution. Okay, here I have another example. Log of x plus 2 plus log of x minus 3 equal log of 6. And I have no base here, that means the base is 10. So I'm going to use this first property here and change and rewrite the left side of the equation as 1 log. So that would be log of x plus 2 times x minus 3. So x plus 2 times x minus 3. You can FOIL this or whatever you do. So it's x squared minus x minus 6. So I'm going to write that here. So x squared minus x minus 6, and that is equal to log of 6. So we have log on both sides with same bases, and we just need to, and they're equal to each other, so that means the arguments should be equal to each other. So x squared minus x minus 6 is equal to 6, and then I'm going to bring the 6 over here, so minus 6, and I will have x squared minus x minus 12 equal to 0. So I have quadratic equations, so let's factor it out. So I have x minus 4 and x plus 3 equal to 0, because negative 4 times 3 gives me negative 12, and if I add them I get negative 1. So if x minus 4 is equal to 0, that means my x is 4. And then if x plus 3 is equal to 0, that means x equals negative 3. So I'm going to check to make sure if both of them give me positive values for the argument. So if I plug in the 4 for the first one, I would get log of 4 plus plus 2, which is log of 6, which is a positive number. And then for the second one, I get log of 4 minus 3, which is log of 1, again a positive number. So 4 is the solution. This one works. And then negative 3. Log of negative 3 plus 2 is negative 1. So that doesn't work for the first one. And then for the second one, it also doesn't work for the second one because I get log of negative 3 minus 3, which means log of negative 6, so that doesn't work either. So negative 3 is an extraneous solution, and then the only solution that works for this problem is x equal 4. Okay, so in this last example that we did, notice that we used that first property to condense the log. And then because we have logs on both sides, we just, with same basis, we just set the arguments equal to each other because of this property. And then we just solve for x. Alright, here I have another example for you to try. It's very similar to the last example that I did. Go ahead and pause the video, try to do this. We'll go over it together. Alright, I have log of x minus 3 base 5 plus log of x minus 2 base 5 equal to log of 2x plus 24 base 5. So I have a plus sign here, so I'm going to use the first property here to condense the log on the left side of the equation. So I would have log of x minus 3 times x minus 2 with base 5. I'm going to do that here. X minus 3 times x minus 2 would give me x squared, using the FOIL method, would give me x squared minus 5x plus 6. So I'm going to write that here. X squared minus 5x plus 6. And then the right side will be the same. And then, because I have logs on both sides and the bases are the same, I'm going to set the arguments equal to each other. So I would have x squared minus 5x plus 6 equal to 2x plus 24. And then if I move this to this side, I would get x squared minus 7x minus 18 equal to 0. So quadratic equation, I'm going to factor it out. I will get nine and 2, so minus 9 plus 2. And then if this one is equal to 0, I'm going to write it here. So if x minus 9 is equal to 0, my x is 9, and then if x plus 2 is equal to 0, my x is negative 2. So we're going to check. If we plug in 9 here, we get 9 minus 3, which is 6, so log of 6. Positive number is okay. 9 minus 2 is positive 7, so log of 7, again, it's okay. And then if we plug in 9 over here, we're still going to get a positive number. But for negative 2 doesn't work in this one. It's going to be log of negative 2 minus 2. It's a negative number. And then log of negative 3 minus 3, it gives me log of negative 5, again a negative number. And then negative 2 works for this one because I get 2 times negative 2 plus 24. It's going to be negative 4 plus 24. It's going to be log of 20, but it doesn't work for this one or this one, so that's an extraneous solution, and the only answer for our problem is x equal 9. Alright, here I have this last example for you to try. Pause the video and try to do this. We'll go over it together. Okay, I have log 7 equal to log of x plus 20 over x base 7. So I'm going to use this property, the second one, to condense the left side. So this is log of this one divided by that one. So I have x squared minus x over x minus 1. So in x squared minus x, there's a common factor of x. I'm going to take that out. So if I factor the x, I get x minus 1, and then it's over x minus 1. So these two would cancel each other, and I'm just going to have x. So instead of that whole thing, I'm going to write that here. So log of x base 7. And then on the other side, I have log of x plus 20 over x base 7. And then I have logs on both sides of the equation with same bases. So I'm going to just set the arguments equal to each other. So I have x equal to x plus 20 over x. And then there's a 1 for the denominator. I'm going to cross multiply these two. I get x times x, x squared equal x plus 20. Then I'm going to move these two to the other side. So I would have x squared minus x minus 20 equal to 0. Quadratic equation, I'm going to factor it out. I would have x minus 5 and 4 and negative 5 because this one is negative. So x minus 5 and then x plus 4. And then if I set this one equal to x plus 4. And then if I set this one equal to 0. So if I have x minus 5 equal to 0, my x is positive 5. And then if I have x plus 4 equal to 0, my x is negative 4. So let's check our answers. If we plug in 5 in here, we're going to get a positive number because it's going to be log of 25 minus 5, which is log of 20, which is positive, so it's okay. And then in this one it also works because it's 5 minus 1, it's 4. And then in that one it also works because it's log of 5 plus 20 over 5, which is log of 25 divided by 5, which is log of 5. 5 is a positive number, so that works. So it works in all 3 of the logs. So that one is a solution. And then for negative 4 works for the first one because we get log of negative 4 squared is 16 minus negative 4, it's log of 16 plus 4, which is log of 20. So that 20 is a positive number, so it works for the first one. But for this one, we get log of negative 4 minus 1, which is log of negative 5, and negative 5 because it's negative, it doesn't work for the second one. So x equal negative 4 is an extraneous solution, and the only solution for this equation is x equal to 5. That's it for solving logarithmic equations. Thank you for watching.